This is an introductory lecture on variables, on the types of variables. Similar information is found in the text, Mendenhall text, on sections 1.2, but I've added some extra information here. The basic divisions on variables are qualitative and quantitative. So a qualitative variable is a category. Typical examples would be the breed of dogs or a blood type. It's just simply a name. Country of origin is a qualitative variable. The quantitative variables are numeric, and they fall into two general categories: discrete, and those are things that are counted, like the number of members in a family, the number of puppies born, something that's counted. Continuous variables are something that's measured. So the discrete variables are integers, well, basically whole numbers, and the continuous variables can be fractions, decimals, whatever. They can also be integers too. Right. For example, you can be 5 feet tall. There's no decimal to that, but it doesn't make it discrete. It's still a continuous variable. Sometimes there might appear to be an overlap between these variables, so you have to look at what exactly at the name of the variable and what exactly they're talking about. For example, say you were looking at the gestational age at birth. Well, you could write that down as how many weeks old the baby is. 20 week, right? 37 week, 40 week, 41 post-term. Okay, that in that case, and of course it could be partial part of that, this would be a continuous variable if you add the fractions to it. Otherwise it could be, you could say it'd be a discrete variable. However, if this information is reported as premature, term, or post-term, then this is a qualitative variable. Whoops. Okay, you see the difference? There are numbers associated with it, but the term itself, premature, term, or post-term, is qualitative. Another example might be that certain numbers are acquired through scaling, through a questionnaire. Say you come up with so many points, say you come up with 25 points, and then you're considered to be mildly depressed. Okay, if you get between 25 and 75 points, then you're depressed, and greater than 75 you have yet another category. Okay, so these these are qualitative variables. You see, they're only names, although there is a scale associated with them. The two examples that I gave showed some numbers that turn into qualitative variables. Although sometimes qualitative variables are represented by numbers, that they do not become discrete variables, and I'll show that in a minute. Oh, first we're going to look at a subdivision of qualitative variables. The qualitative variable can be divided into, or qualitative variables themselves can be divided into nominal variables and ordinal variables. A nominal variable has no order associated with it. It is simply a name. If you took all the last names of the people in your company, those are just nominal variables. They're names. There's no real order. You could say there's an alphabetic order, but that has nothing to do with an experiment or with a value. Okay, and of course you can't do any mathematics on them that has any significance. Now here's a caution that I was mentioning in the previous slide. You can associate a number with a nominal variable, or even the ordinal variables I'll discuss in a minute. So you can associate this number, but that will only be for convenience. For example, you've probably seen computer programs that say enter 1 for male or 2 for female. Now the 1 and the 2 just represent male and female. They are another, in a sense, nominal name variable for the nominal variables male and female. You cannot do mathematics on them. You cannot add, 2 females and a male and get 5. What is that? It has no meaning at all. Okay, and there's no order associated with it. It just, for convenience, was written that way. Sometimes computer programs will assign numbers in order to order things, but it doesn't change it into a quantitative variable. Now we're going to look at another kind of qualitative variable, and that's called an ordinal variable. In an ordinal variable, order can be specified, but you can still do no mathematics, and there's still no amount associated with it. The classic example are the variables good, better, best. There's an order associated with them. You could even give them numbers. You could say good is 1, better is 2, and best is 3. Or you could do it the other way. Good is 1, better is 2, and best is 3. Wait a minute, that's the way I did it. You could go 3, 2, 1 or 1, 2, 3. It doesn't matter. There's an order, and you can use the order of the integers in order to represent the order that is inherent in the ordinal variable. There's a lot of orders in that sentence. Okay, but you got it. Some fields of study like to call the ordinal variable a discrete variable. It is not. You can represent the ordinal variable by a number, but it does not become a discrete variable. For example, if I have a discrete variable like 3 and 5, I can subtract them from each other and get a 2, and it has meaning. If I have good, better, and best as 1, 2, 3, what do I have? Is the difference between better and best the same as the difference between better and good? No, there's no way to organize to state that. So all that the ordinal variable does is have an order associated with it. Another ordinal variable that has a number with it is the pain scale. People are always asked, what's your pain today on a scale of 1 to 10? Well, 10 being the worst you've ever felt, and 0, no pain at all. Okay, so if you're on that scale, if you say 6, does that mean anything? No, it just means it's getting worse, or it's worse than yesterday, or worse than some idea. It just gives an idea. In fact, I don't think it has much meaning at all. But it is represented by a number, and it's an ordinal variable. It just as well could have said, how's your pain today? Mild, moderate, unbearable. That'd be the same thing. Okay, so here we have your qualitative variables, which are categories. They're basically names, and they're subdivided into the nominal variable, which is simply a name and has no order associated with it, or the ordinal variable. The ordinal variable can have an order associated with it, but there's still no mathematics that can be done on it. Either of these can be represented for convenience by a number, but that's only for convenience, and it still doesn't bring any mathematics into the qualitative variable. On the homework and on the exam, I'd like you to be able to differentiate between the qualitative and the quantitative variables for sure, and between the ordinal and the nominal variables. The next that I'm going to discuss here, you don't have to know, but I'm including it for completeness and for those who want to go on in statistics and might need a little bit more background. Qualitative variables can be subdivided. They get subdivided into interval variables and ratio variables, and the difference is whether there's a true zero. Let's look at the ratio variables first. They can have a true zero. Height and weight are true variables. If you have a weight of 0, then there's nothing on the scale. There's a 0. Now that's height and weight. They're continuous variables. They'd be continuous ratio variables. Size of a family is a discrete variable. It has a true 0. If you have 0 members in the family, that's possible. There's 0 right there. But you would have a discrete variable, and that's a ratio variable, and you can still have a true 0. Others are called interval variables. They do not have a true 0. You can see this is a little more complex, and you're not required to know this in 253, but I want you to know these terms so that when you see them, like I say, if you go on for further study, you'll at least have heard these before. An interval variable does not have a true 0. You can look at the difference between the values, but you really can't make a ratio out of them. The classic example is pH. Okay, you can say I have a pH of what, about 3 for stomach acid and a pH of 11 for bleach. All right, you can look at the difference between those values, and that is significant. right? But there's no ratio between the two that makes sense. And if you remember how pH is calculated, you can see why. There's no zero pH, essentially. I mean, the zero pH does not mean there is nothing to it. The same holds for temperature, and I give some information on that in the notes. So I'm not going to talk about these anymore. I just want you to know that there is a subdivision of the quantitative variables into interval variables and ratio variables. So here's just a summary example from the written lecture. So here we show the qualitative variable subdivided into the nominal variable or the ordinal variable. Okay, so these are qualitative variables here, and a qualitative variable is a name, a category of something, gender, religion, political party, zip code. Those are qualitative variables. We can't add two zip codes together and get another place somebody lives. Just think about it. Okay, the ordinal variables, and it's important to know this distinction. Okay, ordinal variables, short, medium, tall, a letter grade, A, B, C, D. Attitude, happy, sad, cheerful. Okay, how about those Likert scales that people like to give, you know, what do you think about something? You know, well, sort of, yeah, I agree, it's really true, you know, all those they kind of give little sayings that you might say to get your opinion on something. Those are ordinal variables, ordinal qualitative variables. They do have an order. There's no really difference between them, and we don't have a zero, no mathematics. And the next group, let's look at those, is the quantitative variables. Okay, a quantitative variable can be broken down or subdivided into an interval variable and a ratio variable. pH and IQ are interval variables. I mean, what's a zero IQ? Well, you might accuse someone of having a zero IQ, and it may be true, but I guess it doesn't have a lot of meaning. Okay, for the ratio variables, height, weight, time, salary, yes, you could have zero salary. Age, you could be 0 years old. Okay, so those are, and then they have an order. Now when you use R or any computer program, they don't call the variables qualitative and quantitative, these different terms. In the computer programming world, the qualitative are called, sorry, I have to vocalize while I try to spell. Okay, the qualitative variables are called character variables. The numeric variables and the quantitative variables are called numeric. And you'll see that in R and in the tutorial for R. So character means qualitative. Quantitative are numeric, and that's it. You know, if you're really programming for mathematics purposes, you can define things as integers, which would be your discrete variables, or you know, a floating point for continuous, but for these statistics programs that's not necessary. It's all taken care of. So character means qualitative, numeric means quantitative, and the other two distinctions in quantitative are discrete, something that's counted, and continuous, something that's measured. There are other attributes or types of variables that show up in statistics. Something you hear is a random variable. What's a random variable? That's a quantitative variable that's determined by chance, like by a game of cards or the lottery, something like that. There's also something called a random number generator, and it is a program that's on your computer or your calculator, and actually there are actual devices that are random number generators, and they attempt to generate random variables, random values. There's an algorithm associated with it, so they're never truly random, but we usually say, you know, good enough. So that's a random variable, something that would happen through a game of chance. Sometimes we need the random variable to do something with, and that's when we use a random number generator. Another type of variable is mutually exclusive variables. We'll see those in probability. For mutually exclusive variables, they cannot both be true at the same time. For example, you can't be dead or alive and alive at the same time. It can't be Monday or Saturday. It's either one or the other. There are other variables, independent or explanatory, dependent outcome variables. We'll talk about those more later in the chapter. And then in the previous lecture, we already talked about the confounding variables. Again, these are variables that influence the outcome of an experiment, but they're variables that either can't or for some reason were not controlled. So,